Hey guys, so today we are going to introduce the topic of topology or rubber sheet geometry. It's section 5.1 in the textbook, and it is an actual live area of mathematical research. In fact, UT Austin has a very active topology group right now, PhDs who are paid to research this stuff. It's pretty trippy. So the word of the day is equivalent by distortion, and we're going to have two different shapes, like 1D shapes like circles and squares, or 2D shapes or surfaces, think like a disc or a sphere, maybe 3D things that have volume. And we're going to talk about whether they are equivalent or not. And I don't mean the same, I mean equivalent by distortion. So what you do is you pretend that they're made of infinitely stretchy rubber. And if one shape can be distorted, if it can be grown or shrunk, if you can pull out little corners and make points, if you can warp it around, and if you can distort one shape into the other, we're going to call those two shapes equivalent by distortion. And the rules are you can't cut and you can't glue, you can't poke new holes. And so that's what equivalent by distortion means. Here are a bunch of 1D shapes. Now, when I draw 1D shapes, obviously on the computer screen, they're going to have width. But for 1D, we have to pretend that they don't. Infinitely thin, right? Because one dimension means no area. So these are all 1D shapes. They, be careful here. This is a circle. Circles enclose area, but they don't have area. Okay, so there's no area to any of these shapes. They are all equivalent by distortion. So if I took the circle and I pulled these little corners out, I could turn it into a square. If that square were made out of a rubber band and I were to soften all the corners and like make a point at the top, I could make a triangle. All of these shapes could be turned into one another if I just had a big rubber band. Here are two-dimensional shapes, right? A disc and a filled-in square. And so there's area, and both of these shapes also have a boundary, right? A boundary circle and a boundary square. And similarly, these two shapes are equivalent by distortion because I could take the disc really easily and just pull those rubbery corners out and make little points and turn it into the filled-in square. And here are two-dimensional shapes. This is a sphere, so please imagine that this sphere is hollow, right? It encloses volume, but nothing in here is actually filled in. If it were filled in, I would call it a ball. And over here, I have a cube with no volume filled in. And these two shapes are equivalent by distortion because I could take a little sphere if it were made of rubber and grab those corners and pull them out, and they would be equivalent by distortion.